Okay. In the second half of last lecture, we have started the discussion of fraud detection by machine learning. And basically, our discussion will give you a working example on working on this data set, which is supposed to be a simplified version of the transaction file between the payment by the department in some large company, okay, in which it, when you read this CSV file, you see that it has only 7 columns because I've simplified it. It has a column called amount, that is the amount to be paid by the department, and also transaction number, the status. The status which has 2 values, pay reconcile and pay unreconcile. That means that pay reconcile, that means that the payment has been made successfully. And reconcile, that means that it's still unsettled, the payment. So this is the status, the department in the company, the fiscal year, the month, and the most important, say, column is the red flag. Basically, this is the model answer. Basically, telling that out of all the time transaction, this those transactions with red flag equals to Y means that they are kind of automatic transaction that need to be taken care of manually. So the whole learning process is to learn how to determine assigning the right answer, yes or no, to the red flag based on these 6 columns. Okay, And basically, we have showed you, or we have emphasized that the major point in this application now shift a little bit, not necessarily focus on the machine learning part, but more importantly is on the part of cleaning the data, because you see that all this data are more or less kind of input by human being, and anything involve human being will involve a lot of mistake or error, and this come up with the most major problem in data analytics: how to clean the data to make it more suitable for analysis. And this is not an easy task. Okay, here I'll just give you some example. The first is showed you how to make use of the function in pandas to detect the missing value. For missing value, basically, is kind of easy to detect. So we will expect that the original data file, because no, when they do the input, if no data is there, then it will say put a special sign, okay, in the Excel file. And based on this, we can use it to when we construct the data frame from this CSV file, then we can convert the symbol used in the CSV file for missing data by a very special word, NAN. Okay, and the reason is easy to understand why we want NAN, because pandas provide some useful method or useful functions that will detect or get useful information related to NAN. Okay, so in order to make use of this function to detect or handle missing value, then we just ask in the very first step to say replace the entry with missing value by NAN. Okay, and then we have showed you some of the function exists to detect, okay, the NAN value. So to show whether that df.any, to show where there's any NAN value in each column, and then sum them up, you see the number of say NAN value in that column. Okay, so we can make use of that. Also, we have function that will automatically remove the row, okay, that in which any of its entry are containing NAN value. Or we can also say replace the NAN value by some particular value, for example, the mean of the data in the data frame. Okay, so this just gives you an example of how to handle the missing value. And also we have defined outlier. Okay, and I won't repeat the definition here, but in the example, you see that the outlier and say the normal value, in particular the Q3, okay, it's supposed to be already very large, and the difference are quite large. So it means that the outlier is indeed, okay, differ from normal value quite significantly in this example. Okay, now what I want to mention in this discussion here is that for most applications, basically in data analytics, basically it will try to remove the outlier. Okay, because we believe that outlier is very exceptional. It will not say contribute any meaningful conclusion. So basically, we just remove outlier. But different applications will have different situations. So for this example, if you remove outlier, you will be in big trouble, because outlier is a very significant indicator that the problem is problematic. Okay, so instead of throwing it out in this fraud detection application, outlier are very significant. So basically, I just want to say, reiterate that data analytics, even whether you make use of machine learning or not, different applications will have different requirements. So basically, what you have learned from example doesn't mean that, okay, the same principle applies to other applications. So you should be very flexible and alert in making use of some general principle. For example, the general principle of removing outlier basically is kind of fatally wrong if you use, okay, in this example. Okay, so it's for outlier, but still we want to detect it, okay? Now, in order to make use of machine learning, basically we also need to make some transformation of the data. For example, in the CSV file, basically its purpose is to communicate between human beings. So its content usually are, say, expressed in a form that it is kind of a way to help communicate with human beings. So, for example, talk about months, and it will use the usual, say, a symbol, for example, JN for January, the first month, FEB for second month. Now, this kind of representation is helpful to human beings, but it is totally a disaster for machine learning. Why? Because it involves some extra information. FEB, JAN. Essentially has nothing to do with the essential information, okay, for our analysis. The essential information is to distinguish the month, whether it is, so if you order the month, whether it is the first month, whether it is the second month. So this is already enough. The way that you represent is JANFEB. This kind of extra information will kind of dilute the important information that really help in the analysis. Okay, so usually this human, say, useful representation must be do some precaution step. We must say remove the unnecessary information and map the, say, this kind of representation to something that will cut all the fact from until the bare bone in order to get the essential information that are necessary and important for our analysis. So as I mentioned, the month, basically we just want to see whether it is the first month, second month. Okay. To be honest, it's not that important. We just want to see, okay, whether it's the first and second month. Okay, so what we want to do, okay, in order before we can apply our machine learning, okay, model building algorithm, we have better to transform, okay, the two columns in this example. The column for months, basically the current representation is a sequence of 3 letters, okay, represent the month today. So we want to map JN to be 1 to 1, FEB to 2, the second month, and so on. How to do that? Basically, pandas has a very helpful function called map. And so if you want to apply it to a particular column in a data frame, so you just specify the column in the data frame and then call the method map afterward. And then the argument of map is a dictionary. And in this dictionary, the key contains a collection of key value pairs. And you will guess what this map will do. It will search the value for each entry in this month column, search whether that entry appears in the dictionary. If yes, that has the key of the dictionary. If yes, then it will use its value to replace it. Okay, so we will suppose that all the possible value of month will appear in this dictionary, and for each of these months, it will have a value for it to map. And here we just use the normal 1, 2, 3, 4, 5 up to 12 to represent the month. Okay, so if you call map and print it out, then you will see that they are all converted to the corresponding number. Okay, but mind you, the value will become a floating point number. Okay, and this is what we want because the machine learning model building algorithms are supposed to work on real numbers. Okay, so this is one of them. Another example is the status column that shows which entry has been complete. Okay, and the mapping basically is the simple dictionary that map pay reconcile to 0 and pay reconcile to 1, and then after the mapping, and then you see the column's new value, something like that. Okay, and I want to bring attention. Okay, and here, because later I may refer to it, that in this data file, it's normal to expect that most of the entry reconcile. Okay, because over the whole year, okay, then the payment should be settled. Okay, if they are normal. Okay, and there may be some reconcile, and either they are have some problems, or maybe that's just a timeline. Okay, for collecting the data that do not have enough time to settle that payment. But that kind of payment should be small. Okay, and the problematic transaction will be almost small. So you will see, okay, if you go through the data set, that most of the transaction will be payment concept. That means the post payment has been settled. Okay, and here just showed you that is just standard data analytics step. Okay, after you have the data, you have to know the data. And the best way to know the data is to use visualization. Okay, one of the most commonly used and helpful visualization method is to generate the histogram. Okay, and once you generate the histogram, you will immediately have an idea on how the value in the data set, distributed. Okay, so first, how to build the histogram. Okay, so you can call the standard pandas graph plotting library PLT. It has a function called HIST for building histogram. And then if you want to see the value distribution of one particular column called, say for example, amount, then we call it amount. Okay, and then you can specify the bin of the experiment. Okay, and next, is a histogram for fiscal years, and then bin is 10. Okay, and now it's been a month, bin is 12. Let me explain now because this is a good example to explain. Well, bin equals to 12, that means that out of among all the possible values, okay, from the smallest one to the largest one, you divide this interval into bins specified here. So in this example, bins is equals to 12. That means that you divide this interval from 1 to 12 into 12 bins. And all the data or all the entry in this column whose value falling into the value between the first bin, that is from 1 to the value smaller than 2, 1 smaller than 2. Okay, in our case, because we have only integer value 1, 2, 3, 4, 5, so this will contain all the value, okay, equals to 1, and this is contain all the value equals to 2, okay, because it's from 2 to smaller than 2, and so on. So in this will be very clearly defined that it will the first bar will show the number of transactions whose month is equals to 1. The second bin contains the total number of transactions whose value is 2, and so on. Okay, so here basically it shows you perfectly how the data is distributed. Okay, but this is not the case for say for example for this example. Okay, because in the first bin it is from 0 now is divided by 25. Okay, totally is 400. I don't know, maybe 100. So all the value is between 0 and 100 here, or 150. Okay, so this is suppose this is the boundary from 0 and smaller than 150. Okay, all the transactions with amount equals to this will be falling into this bar, but you have no idea on what is the exact value. Okay, because it will just kind of putting all those values, similar value will be in the first part, and so on. Okay, so this is histogram. Okay, for this histogram, when you just show the result, immediately you will see that there's something abnormal is there are some say how to say, there's some very large, say, transaction with some very large amount. Okay, and this is the status. Okay, now why I have difficulty explaining it, because you see that in order to clean this out, then I can tell you that there are some value, okay, in the range of slightly smaller than 4,000, but just cleaning the histogram in a normal way, then those important outlier will not be able to be displayed, because the difference between the highest bar and those that appear as an outlier, which is a very small number, basically you cannot see. Okay, so this is one of the common problems that if you want to say find information about the outlier. Outlier means that it is kind of a large value, and it is say much larger than the normal value, so they are rare. Okay, not too frequent, and then you will not see it. Okay, so here are some example, some way to solve the problem. It basically is just to take the log of the value to reduce the height of the highest one, so that you have a chance for the outlier to show up. okay, if you take the log, you just say significantly reduce the height of the highest bar so that, okay, it will close to the lowest bar, and then you will see the lowest bar. And in this example, you will immediately see that, okay, the difference, okay, between the outlier and the normal one is quite huge, okay, because it is a log, okay, relation between them, okay. So this just shows you some common technique to visualize the data. The key point here is we need to understand the data. And there's a lot of technique in data analytics that allow us to get a good idea about the data. One is the histogram, okay? And there's other, okay? But we just don't just give you some example, okay? So I would like to emphasize that this is just an example. If you want to know the complete technique, say a variable in cleaning the data, it will take 1 or 2 more lectures to cover all those, okay, important techniques. Okay, and this may be belonging to another data analytic course. Okay, it just gives you some example on the common technique. Here is another common technique, which is very important for application, is to determine, okay, which column or which feature are most important to that will affect the determination on whether the transaction is possibly problematic. Okay, and in order to find it, so we want to find, okay, the correlation between that particular feature and the correct solution. Okay, that we want to see, okay, whether the value of the feature has a very strong correlation with, okay, the transaction is indeed problematic or that has been fragile. Okay, so in order to do that, so usually almost the case, we will use a standard technique called correlation. Okay, for correlation, basically this is the definition, but this is not you may check it yourself, but the thing to get here is that given 2 columns, if the correlation are a large positive number, that means that they are strongly correlated. And if they are a very strongly correlated, that means that if one, say X has a large value, then corresponding Y will be a large value. So if this is large, then this is large. If this is large, this is large. If it is a negative correlation, that means that if one is large, then the other is small. So they are opposite. So they are related. Okay. So if you know that the 2 columns are highly correlated, okay, then basically giving a large value of one column, then you will say expect that the other value in the same row will also be large. On the other hand, if you find that they are largely negative, then if one is large, then the other is small. So basically, they are related. And usually, if this is 0, that means that the 2 variables are not correlated at all. Okay, and this final finding correlation, the statistic is called covariance. Okay, and here is give you the definition. And what we need to know is that the pandas library provide a function for covariance that you can in the input will be two sequence of number of the same names. Okay, that in return it will give you a matrix. Okay, that has 4 values. The top left one corresponding to covariance of X and X. Okay, basically is called self-correlation. Okay, and the bottom right one is correlation of Y and Y. Okay, while the other entry will be the correlation of X and Y. And it can be seen in the definition that covariance of XY is equals to covariance of YX. They are symmetric. Okay, so basically you just need to look at this number. Okay, look at this number. Okay, so in order to see whether which column are highly correlated, basically is kind of a joke here because we all know that the amount is the major feature that determines the red flag. Okay, but let's just go through it. Okay, so we compute the correlation between amount and the red flag column. You see that is 0.3. This is a very high, say, covariance. Okay, while the others, say months, status, and fiscal year, basically, more or less, they have a very small, okay, 0.02, 0.19, and minus 0.2. Okay, but to be honest, I'm a little bit surprised for the status, because the status may how to say I would always believe that if the status is reconciled, okay, is reconciled, that means that it will better chance that they are problematic, better chance that they are not problematic, okay, because they are complete. Okay, but other thing about it, this is not the case, okay, because I don't know the application. Maybe this involves some money laundering or may involve some illegal transaction. Okay, so basically the amount whether the transaction has been complete or not may not affect directly to the whether this transaction is flat. Okay, this is one possible explanation on that. Okay, but of course for month and fiscal year, well, I cannot see any correlation between whether it is fraud transaction. Okay, so this gives you an example here. Now, another kind of difficult problem that we need to handle for this fraud detection, which is not commonly involved in other application, is that in this, say, application, then in the data set, most of the transaction will be negative. Only a few of them is positive. So you will see that the data set are highly skewed and balanced. You have most of that is negative, say, input, well, only a small amount of them that is positive. Okay. Now, if you follow our standard practice to randomly select, okay, the training data, say for example, you use 80% for the training data set, okay, and 20% for the testing data set. Okay, then usually the 80% data set will have a large number, okay, of negative example, and only a few of them are positive examples. And this kind of small number may not be enough to affect the training to change its weighting to detect this kind of negative sample. Okay, because one of the major, say, advantage or power about machine learning is it will be able to to ignore outlier. Okay, but this kind of data is not outlier. Okay, so basically, it is something that you need to handle. One way to do that is to kind of make the number of positive example, that is those transactions that are fraud, and negative example, make their number more or less balanced. Okay, and one way to do that basically is just to oversample the negative positive example, which is so small. Okay, so you when you do the sampling, you sample more negative example, positive example. Okay, and then pick the negative example accordingly to make the two, say, data sets more or less balanced. Okay, now this is the general idea, but of course there's also many other, say, problems that you need to, say, consider. Okay, based on this simple oversampling example, there's a whole set of different theory on this oversampling, and there are kind of some, say, commonly used example here. Okay, they are from the statistical courses that you may need to learn it, but maybe I will just say give you the name. Okay, so there are some well-developed statistical techniques to suggest how to oversample the data set without causing too much bias in our analysis. Okay, so this is those of the case. So, what is my message? The message here is common to all general data analytic problems when the data set are prepared by humans. And you will see that if you look at more examples, you see that those, say, data handled by human will contain a lot of mistake and error. Okay, so basically, care has to be, say, put enough in order to clean the data set as much as possible. Okay, and also you need to get good idea on the general picture of the data. Okay, before you can do the right analytics. Okay, so the common usual word, garbage in, garbage out. So if you do not spend enough effort to clean your data, basically your analysis will most likely not perfect. Okay, now after that, let us see how to make use of machine learning method to do our analysis. So we have enough data in our analysis. So basically, after that, we can take all the traditional, any of the traditional method, machine learning method. Okay, we find from machine learning for that is for classification. Okay, that is like the one that we explained given the input set data, whether it's apple or pear, but in our case, it's given the input data, whether this is restricted or non-restricted, okay, Y, 1 or 0, as I mentioned. Okay, so this kind of classification problem has sklearn has provided a lot of traditional machine learning methods. Okay, and in this example, I tried some of them, but of course, if you are interested, then you can try all other, say, machine learning methods in order to see how well they are. Okay, now let us go through this one by one. And let me remind you, okay, because later in our discussion, we will go back to the min-max method. If you still remember, given any data, basically, the machine learning algorithm want the data to be some real number between 0 and 1, okay, not any other range. So in our analysis, we will use one particular method, min-max method provided by pandas, that given any age, it will transform it into a number between 0 and 1 linearly. Okay, so this is the formula to do the transformation. Then you see that if x equals to mean, it is 0, x equals to max, it is 1. And since this is a linear function, so the transformation will be linear. Okay. Okay. Now let us go through. Okay. So here is what we are doing, and the data. Okay. I will get it is from the data frame, and so that I can work on this data without make any change of the original data set. Okay, I told you I will make use of the min-max scalar to transform the data. Why I create a new data frame? Because we have shown already that the amount will be the correlation with the among columns and the red flag column are very close, so we will say choose it to our analysis. Okay, then I also choose month and status in our analysis. Okay, and so instead of the whole data frame, I just work on this 3 columns. So the data, new data frame called data that has only these 3 columns. Okay, and what is its value? Basically, I will just call the scalar, which is min-max scalar. Okay, and then it has a function called fit transform that will convert each of the data in this data frame into a value between 0 and 1. So afterward, then this data frame has 3 columns: max, month, and status, and each value will be a value between 0 and 1. Okay, so this is the input data that we will be working on. Okay, now I don't know why I put it here. Okay, so we drop all the missing value in the data, but we have already cleaned the data, so suppose it will not have any NaN value in data. But anyway, I put it here. Okay, so now let's see what it is. The train task split. The first argument is the data frame, that contain each row is a data point, and then you will select a collection of a row for the training and another collection of row for the testing. Okay, so the subset of row for training will be put in the variable x train, and the subset of row for the testing will be called x test. Okay, so this is for the training and testing. Okay, and then the second argument will be the model answer, which is red flag. Okay, and the output will be put at the right training, that is the model answer for the training, and Y test is model answer for the testing. Okay, and and the test size is 0.2. That means that we'll use 20% of the data set as the testing data set. Okay, and then random state equals to 0. Now, why this one? Sometimes when we develop a application software or application program, sometimes it involves random step like this. And after we do the implementation and test the result, we observe something, some arguments that need to be, say, fine-tuned. Okay, but if and then after that we change the argument and we run the program again. But you will encounter a difficult problem here, is because in general, when you call this train test split method, every time you call it, it will give you a different set of splitting. Okay, because it is supposed to be random. Okay, so every time you call it, okay, it will not give you the same output otherwise. Okay, it makes no sense. They want something to be random. Okay, so when you really applying the data set, so you want to be random. But this is kind of say cause some problem if you want to say do the testing, because you want to say fine-tune the data the arguments in order to see whether this changing of the argument, okay, will have some good effect of the output. But you don't want that the changing of output is not because of the changing of the argument, it's just because it just produce, okay, another better, say, splitting randomly. Okay, so you make sure you can confidentially divide into these two effects. So this part, random state equals to 0, just so this 0 is any number that you pick. Okay, but if you type in this one, then any time the starting state will be equals to that number, and then it will proceed to do the random step, and eventually all the random step will be the same. Okay, so this will help you to test and improve your program. Okay, but of course, after say this development finish, you can always say remove it, so that every time the random say splitting will be indeed okay, truly random. Okay, and after that, I just say print the size of the training data set and the size of the testing data set. Okay, so roughly there's 20% of the total number. Okay, so this is the splitting. Then afterward, I will say build a table to summarize all the experiments on different, say, sklearn machine learning algorithm and see how well they perform. Okay, so in this table, basically the first column will be the name of the sklearn algorithm. Okay, they show you the training time, the time for the prediction, how accurately, okay, that the prediction is, and also we have the so-called F1 score, precision and recall, okay, which I will define it okay later. Okay, so basically this shows you all the performance under various measures for the machine learning that I will test. Okay, and here I give you the first example. Okay, and it will say again first make use of sklearn. Okay, if you check the homepage of sklearn, okay, there's a subgroup called naive Bayes, okay, library, and in which it has a machine learner called Gaussian naive Bayes. Okay, so Gaussian ND. And also we import the sklearn matrix to help us to compute the accuracy score, average score, and so on. Okay, and also now here is the part that we're using. Okay, so again and again, I just want to mention that the training part is treated. Okay. So first, we use the library to build a empty, say, framework for this model MB. Okay, and this one is just to say measure the training time, which again is very small. Okay, and then this fit is mean the training. You give the X training data set and Y training data set. After the training, you set the time, and then you just predict using the X training data set. Okay, and then you have the end time in order to see the difference between income and time. Okay, then you have set the training data, then you need to do exactly the training. Okay, so in order to do that, basically, this create a data frame for we are remembering the prediction result. Okay, so this is 90%. Okay, and in order to make the display easier, I just forced to use the test y-test data index to be the prediction index, so that we make the model answer and the prediction have the same index, so that they are pairs with each other. Okay, then afterward, then we just call the learning. Okay, and so how to do the learning? Basically, starting time, prediction time, and one time prediction. Okay, so the prediction is up here. So you just call find the difference between the y-test and prediction. Now, y-test and prediction is a little bit, you have to understand. This accuracy has nothing to do with the actual value of the prediction. It just shows you, okay, whether the prediction and the actual, the true value are the same. Okay, so if they are the same, okay, or they are not the same. So the more the same number of rows, then the higher the accuracy. Okay, but as a matter of fact, after years of application, we find that the accuracy is not a good measure on the performance of the algorithm. Okay, as a matter of fact, we are now working on something different. It's called precision recall, or when combined together, we have so-called the F1 score. Basically, this score is divide the actual value, okay, in a more careful way, so that it will reveal much more informative and correct, okay, conclusion about the performance of the data set. Okay, so so this is in the next slide we will explain how to define this so-called recall and precision. Okay, but the bottom line is the accurate score. Usually, we now agree that they are not that correct to measure the performance of this kind of, say, machine learning algorithm. Okay. Okay. So now let us define precision and recall. Now, for precision and recall, that we need to kind of distinguish the actual value of the prediction. Okay, so we classify all the result into 4 groups. Okay, true positive, true negative, false positive, false negative. True positive, that means that it's saying that it is positive. That means that it is a fraud transaction. And this is the prediction. And true positive, that means that this prediction is true. That means that yes, indeed, okay, the prediction is correct, and that transaction is indeed a fraud transaction or has been red flagged. Okay, so this is called true positive. Similarly, true negative, that means that the predictions say that it is not a, say, red flag transaction, and it is true. Okay, this prediction is true because in the model answer given in the data set, it is indeed a non-red flagged transaction. So this is for correct result. Okay, but it's not like accuracy, lump them up together, but we separate. Okay, that is the false positive, true positive, and true negative. Okay, you have true positive and true negative, of course. Then you have false positive and false negative. So false positive, that means that the prediction is positive, but no, it is indeed not positive. So we make the wrong decision saying that it is positive. And the false negative is saying that you say that it is negative, but indeed it is not. It is a red flag transaction. Okay? So after you have, say, this 4 definition, then it is easy to define what is precision. So for precision, that means that the true positive, the ratio between the true positive and false positive. Okay, and out of this, how many of them are indeed correct? Okay, so what is this? True positive plus 4 false positive. It's the total number of prediction. Let's say it is positive. Okay, so no matter whether it is correct or not, you just lump up or sum up all the prediction by your algorithm. Let's say, okay, the transaction is positive. So include some correct and incorrect. Okay, and then the ratio is the correct answer. So that means that this precision just measure out of all the positive answer you give. Okay, how many percent of them are correct? Okay, so the largest number, the percentage, the more correct that we can trust your answer. Okay, so this is called precision. And another measure is called recall. Now this recall basically is TP plus FM, true positive plus false negative. What is this? Okay, false negative, that means that it should be positive. So this is all the positive in the data set, all the positive in the data set, and you want to find it out. Okay, find all of them out. Okay, then this ratio will show you how many percent of them you can find out. Now, it is quite different from precision. Okay, because it will just look at all the possible answers, all the possibility. data set, this record show how many of them you need to find out. Okay. Now, it is easy to design a method that have 100% precision or 100% recall. The 100% precision will be all zero. Or yeah. So basically, a precision should be now for recorder easier to see. For record, basically your algorithm should say everything to be positive. For record, your algorithm just say everything to be positive. Okay, so if you say everything should be positive, then if you look at all the set of data that are indeed positive, then your answer will be correct. So this is 100%. Okay, so if you do not consider precision, okay, this method will give you 100% recall. Okay, how about precision? If you say, if you kind of say everything is negative, okay, but that will be zero. Everything is negative, okay, the precision will be zero. I'll leave it to you. So anyway, for recall it's easy, okay. So everything is positive. For precision, I would expect that everything is negative. Everything is negative, then true positive, okay, and true positive, okay, and okay, right. So in this case, for precision, then your algorithm should be everything is negative. Everything is negative, then there's no false positive detected by your algorithm. Okay, then you have TP over TP, which is equals to 1. Okay, so basically this already showed you that the original accurate score is not the right score. Okay, because okay, that even though they have high accuracy, okay, maybe okay, this is just biased to one measure. But for our purpose, we want both. Okay, we want the our method have a high recall rate so that it can detect as many positive, say, example as possible. Okay, but also we want them to be accurate because okay, whenever we say positive, we want that it is a high chance it is positive. Okay, so we want both. Okay, and we cannot measure it okay by a single measure, but instead okay we divided precision and recall. Okay, and of course someone indeed want to have one single measure, and this F1 score basically is kind of a acceptable say measure that is kind of take the so-called harmonic mean, okay, of the precision and recall and divide it to 2. Okay, so this is the F1 score. Okay, so basically, we will focus on this 3 score in order to see the performance of the algorithm. You see that these 2 are meaningless in our example because it's okay much less than 1 second. Okay, get the result. Okay, now after using the Gaussian NP, you can try other methods. Okay, here we use logistic regression. Okay, to build the model more or less using the same function call, fit for training, predict for testing, and then we call the I forgot. Okay, so it is already provided by SQL anyway. Okay, I just call the accurate score, okay, F1 score function, and then the precision score function, okay, and then the call score function in order to create the dimension. And here you do it for each of the model repeatedly, okay, and this is the table, okay. And then you see that if you look at the F1 score, basically, the Gaussian MB is very good. And in fact, it's both with precision and recall are both good. But however, if you look at the other, say for example, you look at the accuracy score, okay, and maybe you see that this one accuracy score is 0.93, but its F1 score is only 0.8. In fact, it has a very good precision, but the recall rate is quite unsatisfactory, less than 0.8. Okay, so basically you can just look at this table and compare the accuracy score and F1 score and have a better understanding by looking at the precision and recall. You will indeed find that the F1 score will give you a better detection on the performance. Yeah. And here is drawing a graph, okay, on the performance. Okay. For this part. Okay. So maybe here finish our discussion on fault detection. Okay, so let us try my best to go to the option pricing. Don't worry, okay. I will skip up all the theoretical discussion so that we will have enough time to complete the discussion here. Okay. Option pricing. So for first, what is option? Okay, an option are some financial instrument, something that for the gambler you can say, okay, to play with. So it's financial instrument for people to invest, but these instruments are based on the value of some underlying tradable financial asset, such as stock. Okay, so we will focus on stock in our discussion. That means that the option will depending on the price of stock. Okay, so this is the option on that stock. Okay, and for option, of course, when you buy it, you need to go to the option seller to sell the option. And to sell the option, so you need to sign an agreement, contract. Okay. In this contract, basically, there's a lot of illegal term, not illegal. legal terms, okay? And you can provide it for us. That's only three, okay, things that we need to know. The contract, you specify three things. The first is the expiry date. Later I will explain how it is used. And another is strike price, okay? And then you determine the premium, okay? Premium. Okay, so premium. So basically, it's the price you pay for buying this contract. Okay, so this is the three things. Okay, so this premium is the price of the contract. Okay, so you have the expiry date, strike price, and the price of the contract. So, there are two types of options. And in fact, that's two classes of options. One is from the United States, one is from the European, and they are a little bit different. But what we are not focused on will be the European option. But anyway, we just give you an example on what people are interested in this problem. Basically, in this option, there's two kinds of options. One is called call option, and another is called put option. Okay, how to say this to differentiate these two options? You can imagine put option is for buying the stock. Okay, and put option is for selling the stock. So put is for buying, call is for buying, put is for selling the stock. Okay, and now okay, so what is the buying of stock? So remember, when we sign the option contract, we specify a strike price. For example, the strike price we sign is 65. Okay, what does it mean? It means that the option buyer, okay, has the right to buy the stock on the expiry date, okay, at this price, at the strike price, okay. So no matter what happens, the option buyer has the right to buy the stock on the expiry date at the strike price. Okay, so if the strike price is 65, then if on the expiry day the price of the stock is 100, then I still can use $64 to buy from the option seller buy this stock, which at that day is worth 100. So basically, I have a profit of $35. Then you may ask, what happened if the stock price is lower than the strike price? Okay, I will not be that foolish to buy the stock at the strike price. Okay, this is the catch. Basically, it allows the buyer have the right, to not to exercise the contract. Okay, so the buyer has the right to decide whether it will exercise the contract or not. Of course, if the current strike price is profitable, then it will exercise its contract. If the current stock price is not profitable for them, it will not exercise the strike price. Okay, so basically, in the worst case, the option buyer will lose at most the premium. Okay, we will only lose the option price for the contract. okay, in worst case. But on the other hand, the seller, okay, has the obligation to fulfill the contract, no matter what the stock price is. So as long as the option buyer want to exercise his right, then the option seller can do nothing but buy the stock at the stock price on the expiry date. Okay, so this is what about the option. Okay. This is example, which is just tell you what should you do. It's very easy. Suppose the strike price is 58, okay, and the expiry date is this. So at the expiry date, if the stock price is 64, okay, then of course you will exercise the contract because then you will gain, okay, earn 6, okay, but not 6 because you have, remember, you have paid the premium, okay, it depends on how large is it, okay. But anyway, no matter how large is the premium, okay, you have to exercise it because if you do not exercise, you lost the premium as well as not earning the profit of 6. So basically, if the stock price on the expiry day is greater than the strike price, then you do all the option buyer will exercise the contract, but he may still lose money because it has to pay the option price. Okay. And on the other hand, if the stock price is very low, say 25, then of course the buyer can cut his loss to just the option price. Okay. And here's another example for put price that you check it yourself. Okay. Okay. So this is the example that for call option, then you will find that, okay, the loss will be limited to the stock, the option price that is spent only by the contract, but his profits can be, okay, unbounded, okay, because the stock price can jump as high as possible, okay. But for put option, basically, also the loss are limited to the option price in place, but the profit kind of is limited, okay, because it will gain when the stock price on the, so this is for put options. It will gain, you check yourself, it will gain only when the stock price on the expiry date is lower than the stock price, but the lowest possible stock price is 0. So basically, this is the bar that between, okay, strike price and 0 that we will gain. Okay, so it gives you enough background information for our discussion. Okay, so what I'm going to do is to explain the basic principle that we want to say how to decide the stock price, the option price. Okay, and then maybe we will skip the mathematical discussion on the textbook model, and we will say jump directly to the machine learning method for determining the stock price. But anyway, we need to at least explain the basic principle that we need to follow in order to decide the option pricing. Okay, now okay. So in order to explain, okay, the basic principle on the stock pricing, so we will say start with a highly simplified but unrealistic picture and see what really we want, okay, to be the stock, the option price. So suppose, okay, let's focus on only one, okay? The other option is similar, okay? So let us focus on the call option, that is for buying stock on the expiry date, okay? And suppose when, say, just suppose this highly unrealistic picture. Suppose when the option seller and the option buyer, okay, sit together on one day and decide to sign this option contract, okay, both of them know that, okay, the stock price will not change. Okay, so this is a very stable stock. Nobody, okay, see, okay. Now, I understand this unrealistic. Suppose this is the case. The stock price is, okay, all equals to S over this period, okay? And then agree that the strike price is K, which is, okay, smaller than the stock price on the expiry date. This is the strike price. Okay, so this is the contract. Of course, if you are buyer, you will be very happy because looking at that, you will gain, okay, S minus K. Because on that day, you are going to buy the stock at the current price S with you but need to pay only this K, okay, price. But on the other hand, if you are the seller, you will not be that stupid because you know that you will lose this amount, okay? So what will you do? Of course, in your stock price, you will set into something higher than S minus K. Otherwise, you will definitely lose. But if you set a stock price higher, strictly higher than S minus K, then no one will buy your stock. Okay, because anyone who buy your stock will be foolish because it will lose the money. Okay, so in this oversimplified example, basically we all know that for this one, the option price is definitely clear that you should set it to S minus K. Otherwise, the contract will never be executed. Okay, it's just a game. Okay, now this is what. But of course, this basically is not is not realistic. And in order to make the model more realistic, okay, there's three a researcher in finance, okay, Brad Throw, and then another is merchant. Basically, they have defined a formula for determine the option pricing more reasonably. And their contribution basically is twofold. The first fold is they observe that there's a very important effect on affecting the option pricing. Okay, it's called the free interest. Okay, and then they also devise a probabilistic model which are complicated enough to reflect the real situation, but is simple enough such that mathematical analysis is possible. Okay, so this is basically their contribution. Eventually, we will get we get some formula for setting the stock price. Okay, here is the striking the stock price of the when the contract is signed, and this is the strike price. Okay, and basically later you will see that more or less we can derive S minus K E minus RT this part for you. Okay, but these two are involved in the probability distribution of the fluctuation of the stock price. So they just formulate a simple enough probabilistic model to model the fluctuation of the stock price. Okay, and it's too mathematical difficult, so we can have no way to go through it. But anyway, we just forget about this, say, probability dy, this is S minus K E minus T. Okay, so this is what we focus on. And in order to focus on that, okay, in order to focus on that, basically, we will see basically, we will get the crux of the Black-Scholes formula if we consider, okay, the one more important factor for determine the stock price. Basically, this is what Black-Scholes. So basically, there's something called risk-free rate. So this free risk rate is an investment with zero risk. Okay, it can be the bank rate, so you have a fixed deposit, and the bank will give you a rate. So this rate, okay, in a long period of time, it should be fixed. Or you will buy the US bond, okay, and then the yield will be fixed. Okay, now this is what, okay, this is the situation was when Black-Scholes, okay, do their research. But nowadays, okay, this government US bond yield, okay, it's not that trustworthy. Okay, but anyway, up to this point, Black-Scholes is starting to be replaced by machine learning. But anyway, but still they have the same principle here. Okay, so basically it's a so-called a risk-free rate that every day it will give you an interest, okay, of some, okay, fixed amount. Okay, and this will kind of increase the stock price no matter what. Okay, in theory. Okay, so basically, if you are, say, buying a stock and there's no other particular external effect on the stock, and which follow, okay, the risk-free rate, basically you see that every day the risk-free rate, that is what you get from say a fixed deposit or buying a US bond, every day you will get some interest. Okay, every day, and so the stock price, okay, will try kind of increase under a compound process. Okay, so what does it mean? It means that if you buy, okay, the stock at stock price S, and the day that you buy the option, then the stock price, because of the risk-free rate, okay, on the next day, it will increase by amount of S times R. That R is the risk-free rate on that day. So you can imagine that R is expressed as the daily interest, which is very small. But anyway, this is a rate, so it is S plus the total amount S. So this is the first day. And the second day, you have another factor of 1 plus R to it. So you have S times 1 plus R to be the price after 2 days. And if after T days, okay, then you will expect that the stock price will be S1 plus R to power T. Okay, it is just simple compound analysis, compound interest analysis. Okay, and forget about this one. This basically from calculus, it is okay as well known that this can be okay approximated by E to the power RT. Okay, so what does it mean? E is the natural number, okay, that appear again and again in mathematical analysis. Okay, but anyway, it's just a number 2.718281 and so on. Okay, and what you need to know is the final compound interest will be simply equals to S, okay, very closely approximated by SERT. Okay, so this increase in the stock price are mainly stem from the risk-free rate. So this kind of like a usual performance in general about the stock without any unpredictable event about the stock. So this is what in the highest probability that you may expect. Of course, later we need to introduce some probability distribution on the fluctuation of the stock price, so incorporate into the same model in order to get a better prediction. But anyway, we just look at the fundamental. Okay, so if we assume there's no probability fluctuation outside effect on it, then basically it will follow this straight line. Okay, so according to our analysis, basically, okay, what is the pricing is simply equals to, okay, the difference between S star and K. Okay, so this is the what we want. Okay. So this is the difference between what the buyer will gain. Okay, but then there's another observation that many of us will forget. This is the pricing on the expiry date, in which every day the kind of money will inflated by our percent of risk-free rate. So in other words, if you pay, so for example, if you pay the option seller this money on the contract due date, so this amount of money, say for example this delta, if you pay the option seller this amount of delta on the stop pricing day, then he can use this money to buy the stock using delta, and eventually you will get so remember, this one is for the compound interest. So this is what I want to say. If you look at this one, if at the expiry date, the difference between the stock price after the required number of days for the risk-free rate increase minus the strike price gain, and this is the difference, say for example. And but my point is using this difference, to be the option pricing for the contract sign is not right, because so if it is the price that you pay, then every day you have a risk-free rate to increase. So eventually the number you pay the option seller, then the option seller can be put in the bank for a fixed interest rate, and then it will gain the interest in between. Eventually it will get, according to the compound rate formula, it will gain eventually delta plus ERT on the expiry date. So no matter what, if this is the option pricing, then the option seller will always be the winner, because you get the money. Eventually, at the end, you need to pay your delta. But if you put the money you get on the contract signing day in the fixed deposit, eventually, from the fixed deposit, it will get this rate. So it will be definitely a winner, and this is not a fair game. So what should be the price here? Of course, it want to make it so that after all the interest rate, eventually it will be the difference between the stock price on the starting the expiry day and the strike price. So how to do that? This is ERT. So you want to erase it at the end. So of course, you times E minus RT. So this is E minus RT. This is the option price, okay, that you sign. Then after this date of, say, interest rate increment, then this amount of money will give the option seller. Okay, so this is the amount times the interest rate, and eventually is equal to delta. So in you start it in this way, and basically, okay, the option seller and option buyer with a fair chance to win. Okay, not like this. So in other words, in this situation, the option pricing should be something like this. So let me write it clear out. What is delta? This is delta, okay? Minus K. And the option pricing is this number, E delta E minus T. So this is the formula, okay? So this formula is S, if distributed to E, and it will cancel it out, minus K E minus RT. Okay, so this gives you, okay, this gives you the basic principle on setting the option pricing. And this is a very important observation, because it will take care of the unfair situation in which the option seller can use your contract price to do some risk-free investment of its own, and eventually it will gain more than the option buyers. Okay, so this is a very important observation. And the next contribution about backstroke is to introduce a model to introduce a model that introduce a probability distribution model to model the fluctuation of the stock price. Okay, so that at the expiry date, it have a kind of the expected distribution of the final stock price, and then usually directly put into the formula that you see earlier. Then you will have an average on every possible situation. Okay, and in order to take care of that, basically it gave the formula essentially is based on S minus KE minus RT. This is what we have just arrived. And then the backstroke introduced some further probabilistic modeling, and then based on it, it can just kind of set the expected probability distribution that will affect the stock price as well as the strike price. Okay, and eventually it is just come up with the following objective, okay, formula. Okay, but anyway, for this semester, let us say skip this kindly mathematical discussion. But it's all there. If you are interested, then you can read it carefully. But I will not ask any question in the final exam, so don't worry about that. Okay, so this is what we are talking about stock price. Okay, now, and after all this year, of course, the situation in the world are changing a lot. For example, now the US bond is not that safe, at least okay from my perspective. Okay, so basically the basic assumption of the backstroke are more or less need to be revised. And also, when people really use stock price, and they already find that the pricing usually has dropped and is not that trustworthy. Okay. So people starting to see where there are more, say, adaptive means to, say, adjust the stock price. So one way to do that is to collect enough data and then you train a model so that you use this model, train a machine learning model such that you use this model just like linear regression to suggest a stock price prediction. So in other words, you are not making any, say, human conceived condition that that you feel this is the right conditions, but instead it's just based on the data. Let the data tell you what should be the condition. Okay, and all these conditions are encoded into, say, the weight of the neural network. And one way, another way is that this has the advantage that you can, from time to time, to increase the data set or replace it for more current data set, run the same machine learning algorithm, and get a model that timely reflect the situation. Okay, so this is what a machine learning model is about. And in here, we get our discussion is based on a paper from two Stanford researcher. Okay, and here is the homepage. Basically, it contains all the program, and then you can check it yourself. And the discussion is based on the paper that I have also increased, also include in our lecture notes. Okay. Okay, so this is the paper which have a very good discussion about, okay, how to use option pricing with deep learning. Okay, so we just in our lecture notes, we will focus on one of their implementation, okay, and see how to use machine learning, okay, to do option pricing. Okay, this slide just summarize the problem that we face using the standard method for option pricing. Okay, because people on this problem, okay, find that the backstroke Morton's model kind of become create many problems discovered using this model for option pricing. So basically, people as researchers and try to treat it as a machine learning problem. Essentially, it's a supervised learning for regression just like we give the temperature, we predict the number of cones of ice cream sold. Okay, so basically it is giving the input, then it will expect give you a number respect for say setting the right option prices on that day. Okay, so this is the basically is a supervised learning for regression. And this kind of say method has been done on different areas. Okay, some research will just directly predict the option price. Okay, and some research will predict the volatility. Okay, volatility. Predict the volatility of the stock price. Okay, why? Because in the model, you need to determine, make use of the volatility, okay, of the fluctuation of the stock price. Okay, of course, this basically is used in the probability distribution, but then if you want to use it, then you have to say kind of determine the volatility of the stock price. And usually, there's no good way to determine the volatility over a short period of time. So it just uses machine learning to predict the volatility. This is another machine learning model. And finally, it just kind of use machine learning to estimate the ratio between the option price and the strike price. Okay, so this one is not fix a strike price, but just give you the ratio. Okay, so that it will be more flexible in the negotiation. But anyway, this is some example on using machine learning algorithm to determine option pricing. And we are going to go through one example from the paper that explain or illustrate how to use machine learning model to do the model. Okay, so here the paper say that in the experiment it collect 12 million examples on roughly half call and half put option, and it will train it. Now here the paper has worked on developed a number of examples, but in our this slide we'll focus on one of them, which is the straightforward feed-forward neural network model. And in the model, it will use 98% of the data as the training set, 1% of validation set, and 1% of testing. Okay? To be honest, I'm not that familiar in this field. I kind of can't understand why we use such a large set of training data and a small set for validation. Okay, so I really cannot explain it. But anyway, this is just one set of data. Nowadays, we can have a lot of other means to say collect related option data. As a matter of fact, if you can pay the large sum of money to Bloomberg, then you can also get this kind of data from that. Okay, so but anyway, we are working on this set of data in the paper. And the data set, this gives you a glimpse of the data set. Each entry of the data set contain what? The strike price, and then the stock, this corresponding to the option price, but later I will explain it. Okay, option price, and then the duration, how many days, okay, and then this is the risk-free rate on that period, okay. They use the U.S. bond treasury rate, okay, U.S. treasury rate, and then this is the closing price, that is the stock price on the day of the contract signing, okay, and this is for the volatility, okay, that is estimated by the data set. Okay, so this is the data set. Now, this best and offer basically for the option, people will say bid for the option contract, okay, and then it will use the best offer. So this is kind of the general process that really happened, okay? And this training data model will just use the average of the best bidding price and eventually the best offering price, okay? So the average of it will use as the actual option price in the analysis. Okay, so this column, average of these two columns is for the option price. Okay, so you see that it will have all the necessary data that is used in the Black-Scholes equation, okay, for predicting the option price, determining the option price. Okay, so this is what we have, the strike price, okay, the option review, okay, this is the duration, the number of days that, okay, this is the T, okay, between today, the date was signing the option contract and the expiry date, okay, this is the risk-free rate, closing price, that is the stock price of today, and this is the volatility, okay. Okay. And for the volatility, basically they use the standard deviation of the stock price of the last 30 days. Okay, so how deviations show how volatile of the stock price. Okay, so this is the data. Now let us see how they implement their implement their program. Okay, so again, everyone is using some existing, say, machine learning algorithm. In particular, if you're working on, say, neural network, then a few years ago is TensorFlow, but nowadays is Python. But anyway, okay, they're still using TensorFlow. In the TensorFlow, basically, if we use queries to as an interface for us to free from the matrix manipulation required by TensorFlow, and queries is just helping us to build a model like playing Lego. Okay, and since we are building a feed-forward neural network, so again we use sequential, because sequential means that we feed forward and there's no back signal to the input from the output. Okay, so this is essentially a sequential model, and the layer, every layer, basically will make use of the dense layer, okay, the activation layer, and the RU, the batch normalization. Okay, this is kind of a different configuration of layer as well as the corresponding activation function. And it used a library called backend from queries, okay, to do all the necessary depositing, okay? And now this comment is not important. It just shows you, okay, the actual processing of the TensorFlow, okay? And of course, we need to say make use of an optimizer in the neural network in order to do the training, and we use as usual the atom optimizer, okay? And the usual panda and Python, and also the usual model selection for train and test speed. Okay, now this is the parameter. Okay, but anyway, we will check that later. Okay, now here is to work on the original data set so that it will kind of more suitable for the machine learning. First, of course, we can read the data set from the CSV file provided, okay, using the panda function of CSV. Okay. And we drop the missing value. Okay, access equals to 0 means row. So it means that drop all the rows who has some entry that are missing. Okay, so this will clean up the data set. Okay, and now it will drop the irrelevant row in our analysis, such as, okay, such as volume, open interest, implied volatility, okay, and so on. Okay, and then it shows you the strike price. Now, the date and expiry date is not important here because we have the T, the number of different days. Okay, so the T is basically the basic information that we need, not the exact date and not the expiry date. Okay, but the difference between that. So this column is already now. So we just throw, okay, these two columns already in the data set. So eventually, after throwing all the unnecessary columns, then the data set that we have is the one that I showed you earlier. And now the strike price, okay, in order to make it between 0 and 1. So basically, okay, we divide it, if you look at this one. Divided by 1,000. I don't understand. Okay, the strike price divided by 1,000, and then now the strike price is still 600. Maybe I copied the wrong one. So after divided 100, that should be 0.6, 0.45. Okay, sorry, maybe this is a wrong table I copied. Okay, but anyway, it will divide the strike price, okay, by 100 case, and also and it also divide the, now remember in this data set, it will have both call option and put option, and each of them will give you a CP flag, okay, telling you whether the option you are working on are call option and put option, okay, and these two steps will just separate that, okay, that you just select all the rows with CP flag equals to call option. After this selection, then you drop the CPU flag so that it will not, the current CPU flag, so that it will not in our data set because we are using. Okay, so eventually we have call df, and then we have put df. Okay, so this is the way. Okay. So basically, you have this call option. Okay. So now, after that, then we will work on the call option in this example. Okay. Now, first we need to split the data set. Okay, into test and training. So you see that it is call option data frame. Then basically, as I mentioned, there's a two columns called best fit and best offer, and we want to use these two to determine to estimate the option price. So basically, we just and this is the option price. Now, the average. Here is the model answer. Okay, the label. Okay, so now after using that, we drop these two columns out of our training data set. Okay, so basically we drop these two columns and then use the average as the label. So this becomes the training data set. Okay, with these two columns removed, and then the average of these two columns become the label data set. Okay. Now here, then telling the test data size is 0.01. Okay, so basically it's use 1% of the whole data set to be the testing data set. Okay, and again, as I mentioned, in order for testing or fine-tuning your program, then basically we just set it to a particular number for random state. And that's eventually when you actually run the program, you may remove it. But anyway, when you develop that, you put it here. Now, this is for the splitting of the testing and training data set. Okay, now let us see the model. Okay, it's quite complicated. So basically, we defined a basic model, empty model, which is sequential model, and then we keep on, say, adding layer to it. Okay, layer is 4. Okay, so first we have a dense layer with the input shape is the training data set shape. Okay, and the unit basically is equals to 400. That means that this is a input layer okay. So this is the first layer. And after adding the first layer, then we add another layer whose construction is called lead RELU. Okay, and well, I don't go through the structure of this one. So basically, is some say neural network construction that make use of the commonly used regular linear unit in the application. So this is another layer, and then it will on top of that build 4 more layers. Because layer here is set to 4. It's from range is 0, 1, 2, 3. A range. Layer is 4, minus 1 is 3. So we have only 3 more layers. This for each iteration, it will add a dense layer with 400 units as the output. Together we will say add a batch normalization on it, and then add a leaky, say, regular unit. Now basically what it wants to do is to have a dense layer, and then out of the dense layer, it build another, say, well-purposed layer to do some more modifying of the signal to make it, say, easier for the training. So this is one. And next, we'll keep on adding another dense model on it, but the output will not directly connect to the next dense model, but instead go through some neural network model that are known to be doing some normalization and will have some use of linear reduce linear unit in order to, say, do some modification of state. So this is basically kind of help the dense unit to get more useful information. This is the one basic unit, and then we do it 3 times in order to, say, make sure that it has enough processing of the data to get the model that we want. And then finally, we just use dense layer to combine all the nodes, all the output into one single node, using it as a regular unit. That means that it will be equals to 0 if it is negative. Otherwise, it will be the weight average of the input of the edges. And this will be used to estimate the true option price for the data. And then we use atom optimizer to find the optimal weighting, which will minimize the loss function. Remember, we have no, say, strong enough mathematical tool to minimize the accuracy. So usually we will use something approximately well approximate the accuracy. Here is the mean square error, the approximate. And then compile the model, and then we train the model. So here is the usual stuff. We will use training, X for the data set, Y for the label, and we have the batch size, number of echo. Now I want to pay attention. This model has a flag for validation spring. So basically, you can also instruct in the training that in each round, once you finish it, then you can use this 1% validation the data to validate the output. So this is followed directly what the model that we mentioned at the very beginning of our discussion. namely that we split the data into three sets: the training data set, the validation data set, and the testing data set, in which the training data set and validation data set basically is used through all the training, and the testing data set are only used once, okay, to final evaluation. Okay, and call back this TensorBoard, forget it, okay, because you run it, it tells you how the TensorFlow work on each of the steps. Okay, and then after that you call prediction, and then you get the difference between the test value and then the predicted value. Okay, and see the difference, find the mean, and then you get the final result. Okay, so now it just goes through this simple algorithm for you. And if you are interested, the paper also have other models. Okay, and if you are interested, then you can go through the website in order to try the model. Okay, so I understand that it's kind of superficial for this option pricing discussion, but anyway, I hope that I can at least give you some basic principle on this option pricing problem, and show you that it is quite, I don't want to say straightforward, but it just follows, okay, the usual step in using machine learning method to solve our problems. Okay, so now this is the end of our discussion here, and so sorry I do not have to take a break, so that I just want to make sure that I can finish it. Okay, so basically this is what I want you to teach you after this point. Okay, and the next following 2 weeks, I expect you can teach me some more interesting stuff. Okay, so I really look forward to that. Okay, as a matter of fact, from the last few years, some of you are doing something really surprising, and I learned a lot from that. Hopefully for this year, okay, I can have this kind of, say, learning experience for you. Okay, and for this, okay, that basically, that some of you has asked me the question, maybe I can say give you the answer now. Because first, okay, before the presentation, you can always change your topic, but you may send an email to our TAs, okay, to alert them you have changed the topic. Okay, and secondly, for the project report or the presentation, you do not need to submit it before the presentation. Okay, so your presentation, you can just display your PowerPoint. Okay, of course, at the end, you need to submit both of them, but not necessarily, okay, before the presentation. Okay, and each presentation lasts 15 minutes. Okay, so try your best to make your presentation as excellent as possible. Okay, to impress me, I will be very happy. Okay, so I'm looking forward to your presentation in the next 2 weeks. Okay, remember, so we have 3 parallel sessions in 3 different classrooms. So you need to make sure which classroom you need to go for your presentation. Okay, you should not just come to this classroom and find that, okay, this classroom is not for your presentation, and then you can need to run all the way back to Cherry Hill Building. So from one end of the campus to the other end, okay, it's quite an exercise. Okay, so any question? Okay, good. Okay, thanks a lot for saying your patience for the last 8 weeks. Okay, and feel very happy to say have a good communication with you. Okay, so if not, then maybe we stop here. Thanks again.
我想問咧，PowerPoint 咧係有冇話一定要喺 present 之前 upload 上 Moodle？我啱啱答咗你咯，嗰個就係。唔係，但係你話。